Let's study Doppler's effect in reflected sound. In this situation, we can see a picture in which a car is approaching towards a fixed wall, and say if the car sounds a horn, the waves are traveled towards the fixed wall, then these are reflected, and again reflected sound is approaching towards the car. So if we talk about the apparent frequency which is observed by the driver while sitting in the car, this will be certainly different from the actual frequency. However, the wall may be at rest or may not be at rest. In this situation, there is a specific way to handle such kind of problems. The first method by which we can handle such problem is we treat wall as a stationary receiver which receives the frequency from the moving car as an observer, and then the frequency it receives is reflected as a stationary source, and then the car driver will hear the sound which is coming from the wall as a stationary source, and we treat the source to be of that frequency which it was receiving from the wall as a moving source. See, step by step we handle it. First, these are method 1. We'll also understand another way to handle this problem. First, we consider wall as a stationary observer which receives the sound of frequency, say NR. If say the frequency which car is producing is N0, then this NR can be directly given as N0 C by C minus Vc, as we are treating this wall as an observer and car is approaching. So the frequency the wall will receive NR can be given by this expression. This is here equation 1. Now the wall will emit the waves of this frequency in the opposite direction, and if we find out the frequency heard by driver as a moving observer is N apparent, this implies we use N apparent to be equals to, here we treat this wall to be a source of frequency NR which is at rest, so it can be taken as NR multiplied by C plus Vc by C, because now the observer, which is the driver, is moving with the speed Vc and it is approaching towards the wall. If we substitute the value of NR from this expression, we'll get this N0 multiplied by C plus Vc by C minus Vc. This is the final frequency or the result of frequency which the driver of car is hearing. In such cases, there may be a situation when wall is moving, there may be a situation car is moving in some other way. So we'll use the expression of Doppler's effect which we already studied, just we break it in 2 steps. In a step 1, we treat the reflector, the wall or reflector as an observer initially, and later we treat the wall or reflector as a source of same frequency which it has received. This is the way how we analyze it. The same problem can also be solved by using another method. Let's have a look on that. In method 2 or alternative approach for the situation of the calculation of apparent frequency of reflected light, here we treat this wall or reflector as a mirror, and say if in front of a mirror a car is moving or a source of sound is moving, we find out its image as if this is acting like a mirror, and we assume if car is producing a sound of frequency N0 which is received by the wall and it is reflected, we assume that this reflected sound is coming from the image of this car which is also having a frequency N0. Now in this situation, if this is considered to be a frequency N0, this reflected sound can be directly considered to be coming from this source, so we can directly find out the apparent frequency heard by driver as n apparent, we can write as n naught, which is the frequency of this image from which this reflected sound is coming, in which we can say the observer is approaching the image, as well as the image which is actually treated as a source of sound is also approaching the observer, as which is the driver of car. So it can be directly written as n naught multiplied by C plus Vc upon C minus Vc. You can see here directly we have obtained the same expression which we have calculated by taking this wall as an observer which has received a frequency, and then it has emitted the same frequency as a stationary source which was heard by the car. So this can be handled directly, but I personally prefer it to be used only in cases when wall or reflector to be at rest. If wall or reflector is moving, then this is applicable only for some specific cases when the speed of wall, reflector or source or observer are very small compared to the speed of sound. Otherwise it won't result properly. So this should be used whenever the wall or reflector to be at rest. This will give us the appropriate results.